In this video, I will show you how to use CrossSections program. The CrossSections program inside the Unzoid called min-max search. It's cross-section, but it was based on the min-max search code on the same project. When you double-click to open, after it opens, you can see that it's very similar user interface, but it still is. There are differences. For example, here is tau search options, and you have just one text box, and then you have another text box for points near. We uncheck get x from another file. We use files with x, the files that were generated by TxtShuffle on Nematicity. Click browse, and here I prepared one file from Nematicity program to show how the cross-section works. I go to my example out, I choose it, and I open it, and then I load. You can see I have 41 scans here, fluence dependent. And first important moment that even though here I have my x coordinate in time, and here I have my point number as a point, and I know that 0 point is this point, the first point minus 45 picoseconds, the last point is 1.5 picosecond. For cross sections, I need to write here my time axis in picoseconds, or in this case, in the units of x-axis, not in the number of points. So in this case, it's a little bit inconvenient. I need to know which positions I want to check in advance. For this reason, I can import my file to origin, and I can check it in the origin which positions I actually want to get. For example, here, let's go to the last one. Here I can choose, I can look, and for example, I will go for minus 200 femtosecond, minus 0.2. I will check 0, I will look exactly at 0. I will look around 200 femtosecond and 0.2 picosecond. And then I will look at the closer to the end, 1.5 and 1 picosecond. So, and then I start writing 0.2, then I use comma. It means the next value is 0, comma, then the next value is 0.2, no spaces, comma, 1, comma, 1.5. Then I choose how many points near I want to average to get the cross section still, because realistically there are a lot of noise and I want to get a smooth dependence of my cross section versus fluence. For this case, I can go and I can look directly into my data, how much points is, for example, here. One way to do it in the origin, to look how much the data is equidistant. So, for example, here 6,270, and this is something like minus 144 femtosecond. And then I go to 100 points. It will be something here, it will be still minus 133 femtoseconds. So it's 100 points, 200 points is around 10 femtoseconds in this case. So for this reason we do not average over vast time, so it's fine in this approximation. If I choose less, then the data will be noisier. If I choose more, for example, 2000 points, it means that right now I'm averaging over bigger area. So it's not exactly a cross section, it's more like some averaged response. after I choose this, for this program specifically, it's important to change name in advance. So after I put my time, I put my points, I change the file name, and only then I click search for, because it will search and it will automatically save the file. So while it's done, save done, I can go and I see that it added the file and it also adds this cross-section.txt. Right now I can go to origin, I can import the file, I can see what it saved. And as you can see, I have all of my cross-section minus 0.2, 0, 0.2, 1, 1.5, as I expected. Here, how they look.